Hello everyone, I'm Haoran Zhang from School of Electronics and Information Engineering, Harbin Institute of Technology. Our research title is Multi-User Set Access Research in Cell-Free Massive MIMO. First of all, I'd like to introduce the background of this paper. The three major business scenarios of 5G include enhanced mobile bandwidth, massive machine communication, ultra-high reliability and low latency communication. In the application of the Internet of Vehicles, the ultra-high reliability scene is the mainstream. From the perspective of ultra-high reliability, the current cellular-based network architecture is no longer suitable for the continued evolution and development of the Internet of Vehicles. In the scene of high-speed vehicle movement, the traditional cellular architecture inevitably has the inherent defect of inter-cell handover, which causes the complicated signaling overhead and decrease of reliability. Cell-Free Massive MIMO is proposed as a new type of distributed network architecture, which uses a large number of distributed antenna access points to serve a small number of users distributed in a large area. All units are connected to the central processing unit through the backhaul link. So there is no concept of cell boundaries. The current papers are really research on how to combine Cell-Free Massive MIMO and NOMA in the downlink. To combine Cell-Free Massive MIMO and MUSA, our research is as follows. As shown in Figure 1, this article considers a cell-free network composed of k single antenna UEs and L access points AP. Each AP is equipped with an antenna and is arbitrarily distributed in covered area. These APs are connected to the edge cloud processor in any way called CPU. This kind of setting can perform consistent joint transmission and reception for the UE in the entire converged area. And when L and K are large, it is called Cell-Free Massive MIMO. Usually assume that L is larger than K, that is, the number of APs is more than the number of users. It is assumed that the AP and the UE perform transmission according to the TDD protocol, where the TDD duplex includes an uplink transmission pilot phase and a downlink data transmission phase for channel estimation. Assuming that the channel parameters of different APs are independently distributed for the channel parameters. Suppose there are p mutually orthogonal pilot signals of length tau p, where tau p is consistent independent of k. When UEs access the network, they are allocated to UEs. When these UEs send pilots The received signal at the AP is above. After using the MSE for channel estimation in the uplink, the channel reciprocity can be used to obtain the downlink channel information at the same time. This scheme avoids downlink channel estimation and can save a lot of pilot overhead. Let WIL denote the precoding allocated to the UEI by the APL. During the downlink transmission, the received signal at the UE is above. Pilot pollution often greatly reduces the performance of Cell-Free Massive MIMO, and the cause of pilot pollution is that multiple users share the same pilot. In order to reduce pilot pollution and make full use of limited pilot resources, this paper proposes a solution for user clustering. That is, users in a cluster share one pilot, and different clusters use different pilots. Non-orthogonal multiple access technology (NOMA) to decrease users. In this way, the influence of pilot pollution is effectively avoided, and the spectrum efficiency is improved. As shown in Figure 1, we divide users into key clusters. Tentatively, there are 2 users in each cluster. There are 3 clustering schemes, namely random clustering, closest clustering, and fastest clustering. In this paper, the first scheme is randomly clustered for modeling, and the other 2 schemes are waiting for in-depth study later. Because the channel hardening phenomenon is a reasonable assumption, therefore, users use channel statistics to perform serial interference cancellation (SIC), relying on the average value of effective channel gain as an estimate of the channel gain. Based on the above conditions, the achievable rate can be rewritten, and finally, we can derive the spectrum efficiency. We set up a scenario in which of LAPs and KUEs. Assume that APs and UEs in the area have only a single antenna. Specific configuration parameters are shown in Table 1. It can be seen from Figure 2 that the improved Cell-Free Massive MIMO system has a greater improvement in spectrum efficiency. The reason is that the extent of clustering improves the utilization rate of pilots, thereby increasing the resources used for downlink data transmission, which effectively improves the spectrum efficiency of the Cell-Free Massive MIMO system. The extent of MSE precoding and SIC suppresses the interference between users of multiple users in the same cluster, thereby improving the overall signal to interference and noise ratio of the user receiver, and also has a great effect on enhancing the spectrum efficiency. Considering the influence of interference between users, this paper also explores the user service carrying capacity of this scenario. The specific method is the total number of users accessed is adjusted, and the number of users per cluster is still 2. Count the spectrum efficiency of all users. It can be seen from Figure 3 that as the number of users access increases, the total spectrum efficiency of the Cell-Free Massive MIMO system has a tendency to increase first and then decrease to 0. This is because when the number of users is appropriate, the sum rate of the system increases as the number of users increases, and the corresponding inter-user interference is not enough to reduce the total spectrum efficiency due to the small number of users. However, when the number of connected users reaches a peak, there will be users accessing again, which will cause the spectrum efficiency of the system to decrease. This is because the spectrum efficiency is also related to the effective correlation time. An increase in the number of users will lead to an increase in the number of pilots, thereby reducing the time of data transmission. Therefore, it can be concluded that the number of users that the Cell-Free Massive MIMO system can access has a certain limit, and blindly increasing user access will only cause the loss of system performance. In order to specifically analyze the changes in the spectrum efficiency under UHR number scenario, this paper also studies the average spectrum efficiency. Keep the number of users in each cluster at 2 and change the total number of users connected as shown in Figure 4. It can be seen that the average spectral efficiency of all users will gradually decrease as the number of users increases, until it decreases to 0. Compared with the system before improvement, the average spectrum efficiency of the system after the improvement decreases more slowly, and the number of users reaching 0 is also more than that before the improvement. This shows that improved system has greater user carrying capacity, because the relevant resource blocks are limited and the number of users contained in each cluster is fixed, both of which are 2. Therefore, the increase of the number of users will increase the total number of clusters in the area, thereby increasing the resources occupied by the pilot and compressing the resources for downlink data transmission. As a result, the spectrum efficiency will gradually decrease as the number of users increases. The improved Cell-Free Massive MIMO systems has better user bearing capacity because the clustering algorithm improves the optimization of pilots. In this paper, the Cell-Free Massive MIMO system improved on the MUSA norma, and a clustering method is proposed. Users in the same area are divided into clusters according to random matching. Each cluster contains 2 users. Users in each cluster share the same pilot, and different clusters use different pilots, thereby improving the utilization rate of the pilot. Users in the same cluster use MUSA to distinguish cododerms and use MSE SIC to detect multi-user information. The result shows that the improved Cell-Free Massive MIMO system has better spectrum efficiency. In the future, we plan to change the number of users in each cluster, which may improve the spectrum efficiency and consider different clustering methods. That's all. Thank you.